Hi everyone, in this video you have to find the first derivative of the inverse function at a given x. In question number 1 we have the function f of x equals 2x to the fourth power plus x cubed plus 3, and in part A you have to find the derivative of the inverse function of f of x at x equal 3. So firstly you have to find f prime of x. This is the first step. So f prime of x equals 8x cubed plus 3x squared, and this is the first derivative of the function f. In the second step you have to guess a number x that you have to replace it in the original function f of x to get 3. So by guessing you can see that f of 0 equals to 2 multiplied by 0 to the fourth power plus 0 cubed plus 3, which give us 3. So this gives us the number x in the question. So this is the second step. And the third step you have to rewrite step 2 in terms of the function f inverse of x. Now since f of 0 equals to 3, this means that f inverse of 3 equal to 0. Next you have to use the rule of the derivative of the inverse function, and this is the rule in step 4. We want to find f inverse prime at x equals 3, and this is equals 1 over f prime of f inverse of 3. Now f inverse of 3 is equal to 0, so this is equals 1 over f prime of 0, and equals to 1 over f prime of 0. You have to replace x equals 0 in the derivative function and you will get 0. So f inverse prime of 3 is undefined for part A. In part B you have to find the derivative of the inverse function of f at x equals to 4 with the same procedure in part A. Firstly you have to find the first derivative, so f prime of x equals 8x cubed plus 3x squared. Then you have to go to the next step, step 2. You have to guess b such that f of b equals to a. So you have to replace a value of x that give you 4. So by guessing, if you replace x equals to -1 and find the value of f of -1, you will get 2 multiplied by -1 to the fourth power plus -1 cubed plus 3, and this is equals to 2 minus 1 plus 3 equals to 4, which give us the number x in the question. So f of -1 equals to 4. Now you have to go to the next step, step 3. You have to rewrite f of -1 equals to 4 as f inverse of 4 equals to -1. Now we have gonna go to the last step, step 4. And in step 4 you have to find f inverse prime of 4, and this is equals to 1 over f prime of f inverse of 4. Now f inverse of 4 equals to -1, so this is equals 1 over f prime of -1, and f prime of -1 means you have to plug in the value x equals to -1 and the derivative function, and you will get 1 over 8 multiplied by negative 1 cube equal negative 8. Negative 8 plus 3 equals to negative 5. So this is the derivative of the inverse function at x equals to 4. In question 2, we have the function g of x equals to x plus sine x, and you have to find the derivative of the inverse function at x equal to 0 in part A. So firstly, step 1, you have to find the derivative of the function g of x. So g prime of x equals 2 plus cosine x. Now in the second step, you have to guess a value of x that give you 0. So by guessing, you can see that g of 0 equals 2 times 0 plus sine of 0. And this is equal to 0. So g of 0 by guessing equal to 0. Now you have to go to step 3 and rewrite g of 0 equals 0 as g inverse of 0 equal to 0. Now the final step, you have to find the derivative of the inverse function at x equal to 0. So you have to find g inverse prime of 0, and this is equals 1 over g prime of g inverse of 0 equals to 1 over g prime. Now g inverse of 0 equal to 0, so the final answer will be 1 over, now you have to replace x equals 0 in the derivative function, and you will get 2 plus cosine 0, but cosine 0 equals to 1, so you have 2 plus 1, which is 3. Now in part B, with the same manner, in part A, step 1, you have to find the derivative of the function g of x. This is equal to plus cosine x. Then by guessing, you have to find a number x such that g of x equals 2 pi. So you can easily see that g of pi equals 2 pi plus cosine pi plus sine pi, sorry, because we are talking about the original function g of x. So sine of pi equal to 0, and you will get 2 pi. So when we replace pi, you get 2 pi, which is the number required in this question. So g of pi equals 2 pi, and this is step 2. Now in step 3, you have to rewrite this as g inverse of 2 pi equals to pi. Now the last step, you have to find the derivative of the inverse function at x equals to pi. So you have to find g inverse prime of 2 pi, and this is equals 1 over g prime of g inverse of 2 pi, which is equals to 1 over g prime. Now g inverse of 2 pi is given and equals to pi, so g prime of pi, and this is equals 1 over, you have to plug in the derivative of, in the derivative of g, x equals to pi, so we have 2 plus cosine of pi, and cosine of pi equals to negative 1, so this is equal 1 over 2 minus 1, which gives us 1. In example 3, you have the function h of x equals x plus log x to the base 2, and you have to find the derivative of the inverse function at x equals 1 in part A. So firstly, you have to find the first derivative of h prime of x equals 1 plus the derivative of logarithmic function is the derivative of the inside function, which is x, so we have 1 over x multiplied by len the base len 2. This is step 1. Step 2, you have to guess a number x such that h of x equals to 1 in our equation. So it is easily to find that if you replace h of 1 in our function, you will get 1 plus log 1 to the base 2, and log 1 to the base 2 equal to 0, so we have h of 1 equals to 1. Now you have to go to the next step, and you have to rewrite this statement as in terms of the inverse function h inverse. So we can rewrite it as h inverse of 1 equals to 1. And finally, you have to use step 4 to find the derivative of the inverse function at the given x. So h inverse prime of 1 equals 1 over h prime of h inverse of 1, and h inverse of 1 equals to 1, so this is equals 1 over h prime of 1. H prime of 1, you have to replace x here, and you'll get 1 over 1 plus 1 over len 2, and you can simplify it more. Put the simplify in the comment. So this is the solution of part A. Now in part B, you have to find the derivative of the inverse function of the function h at x equals 3. So first you have to find h prime of x, and h prime of x equals 1 plus 1 over x multiplied by len 2. Then you have to guess a number that if you replace it in h, you will get 3. So if you replace x equals 2 in the function, you will get h of 2 equals to 2 plus log 2 to the base 2, and log 2 to the base 2 equals to 1, so you have 2 plus 1, which is equals to 3. So we get the number we want in our equation. Now this means that h of 2 equals to 3. Now you have to go to the next step, and you have to rewrite this one as in terms of h inverse. So this means that h inverse of 3 equals 2. Finally, you have to use the rule of the derivative of the inverse function. So you have to find h inverse prime of 3, and by the rule this is equals to 1 over h inverse, or h prime, sorry, for h inverse of 3. Now h inverse of 3 is given and equals 2, so this is equals 1 over h inverse h prime of 2. H prime of 2, you have to replace it in the derivative function, and you will get the final answer. So h inverse prime of 3 equals 1 over, now replace 2 and the derivative function, and you will get 1 plus 2 len 2, and this is the final answer, but you have to simplify it more. And this is question 3. In question number 4, we have the function f of x equals tan inverse cosine of x in the interval from 0 to pi. This interval is very important to make the function 1-to-1 function, and 1-to-1 function means the function is invertible, so have f inverse in this interval. So firstly, step 1, you have to find f prime of x, and f prime of x, as you know, for tan inverse d by dx, for tan inverse of a function inside equals u prime divided by 1 plus u squared. So first you have to find the inside function derivative, so this is equal minus sine u divided by 1 plus cosine squared of x. This is the derivative of our function. Next, in step 2, you have to guess a number if you replace it instead of x, you will get 0. And it is easy to find that if you replace pi over 2 in the function, you will get f of pi over 2 equals tan inverse of cosine pi over 2, and cosine pi over 2 equal to 0, so we have tan inverse of 0, and tan inverse of 0 equal to 0. This means that f of pi over 2 equals to 0. F of pi over 2 equals to 0. Now in step 3 you have to rewrite this statement in terms of f inverse. So this means that f inverse of 0 equals pi over 2. Now the last step, step 4, you have to find the derivative of the inverse function at x equals 0. So f inverse prime of 0 equals 1 over f prime of f inverse of 0. From the previous step, we found that f inverse of 0 equals pi over 2, so we have f prime of pi over 2, and this is equals 1 over, here you have to replace pi over 2 in the derivative function, so you will get minus sine pi over 2 over 1 plus cosine squared pi over 2, and this is equals 1 over, now negative sine pi over 2, sine pi over 2 equals to 1, so you get negative 1 over, and sine pi over 2 equal to 0, so we have 1 plus 0, which is 1, and finally we have the answer negative 1. So negative 1 is the derivative of the inverse function of f at x equal to 0. And that's it. Thank you.